Hello students, I'm just going to talk you really quickly through the activity that we did in class, or will do in class, with right triangles. So basically we had everybody create a 50, 40, 90 right triangle. Everyone's triangle was a different size, but they all had those angles there. And so then I had them circle that 50-degree angle. We're going to call it theta, and then label the hypotenuse side of the right triangle, the opposite leg, and the adjacent leg. And then have everybody measure all three sides. Now, hopefully then everyone's, all three sides are going to be different just across the board. However, there is something that's going to be the same, namely the ratios. And so I have everybody calculate with the calculator what is the ratio of their opposite divided by their hypotenuse, the adjacent leg divided by hypotenuse, and the opposite divided by the adjacent for their particular triangle. And as it turns out, there are nicknames for those ratios, which would be the sine of the 50-degree angle, the cosine of the 50-degree angle, and the tangent of the 50-degree angle. And so then we're going to we get everybody's results and have them compare to each other, ask, okay, why are they different? And in this case, it just boils down to people not, students not measuring that angle properly, or maybe rounding incorrectly or measuring one of these correctly. But if they measured everything correctly and drew it properly, then it will get exactly the same answer. And the next question, the follow-up question, is there a correct answer, or is this something that just everyone's always going to have slightly different? And the answer is yes, there actually is a 100% correct answer if we had very precise methods, very precise equipment, and it's not too hard to do as long as you're paying attention in the classroom. Yes, and there were some math monks who were very good, very precise, had great equipment, a lot of extra time on their hands, and they made triangles with a 50-degree angle, a 51, a 52, a 53. They measured all the sides and they calculated those ratios, and they stored them in tables and they wrote them down in books. And now that information is stored in a calculator as a lookup table, though there's other ways of doing it, but I'll talk about that later. Anyway, so for our purposes, we just have to realize that there were some people that went out and measured, made a 1-degree triangle, a 2-degree triangle, a 1 or 2, 3-degree right acute angle there in a triangle, and then drew it out, measured the sides, and then took those ratios and did the long division and came up with some really accurate answers. And we are going to use that information. Then we talked about two special right triangles, and wanted to kind of do that process by hand. So 45, 45, 90, have everyone create, have everyone measure, and then calculate what are the ratios, and hopefully the tangent, this leg over this leg, is going to be 1, because if it's 45, 45, then by definition that's going to be an isosceles triangle, or by the fact that opposite angles in a triangle have congruent angles, the sides opposite them will be congruent sides. That's the property. Anyway, should have 1 there. And then another special triangle is the 30, 60, 90 triangle. And everyone will draw different triangles of different sizes. However, those ratios, the ratio of the opposite over the hypotenuse, or the opposite over the adjacent, or the adjacent over the hypotenuse, so those ratios will be the same, or at least they should be as accurate as we are. And then to wrap things up, we use the Pythagorean theorem to figure out exactly what should those answers be, rather than me just saying, well, let's look and type it in the calculator, because actually there is an exact answer even in radical form. And if you have a right triangle that's a 45, 45, 90 triangle, you can just use Pythagorean theorem to figure out what that hypotenuse is. So x squared plus x squared equals c squared. So that would be 2x squared equals c squared. So c squared is the square root of 2x squared. That x can be brought out due to our radical properties. And so that hypotenuse is x, whatever those legs are, times the square root of 2. So all 45, 45, 90 triangles will follow this pattern: x, x, x root 2. Whatever x happens to be. If maybe it's 42 meters, and this one's 42 meters, and this will be 42 times the square root of 2 meters, whatever that number happens to be. And then we built the same thing. Now don't look at this triangle down here, but just focus in on this top one, the 30, 60, 90 triangle. And then we say, okay, let's just reflect that across this leg. And we have a 30 and a 30 right here, which would be a 60. That 60 up here is now reflected down here. We have a 60-degree angle here, 60-degree angle here, 60-degree angle here. And our geometry reminds us, hey, that's an equilateral triangle. So for the purposes of simplifying, we said, okay, let's call this leg right here that's across from the 30, we'll call that the x, call that length x. And therefore then this must over here be x, since we just reflected the triangle. So this whole length right here is 2x. Thus, this side over here is 2x, and this side down here is 2x, and it just so happens that this side here is the hypotenuse of that first right triangle, the 30, 60, 90. And so we say, okay, we've got x, and we've got 2x. We can use Pythagorean theorem now to figure out what is the length of this other leg. So Pythagorean theorem, a squared plus b squared is c squared. So we have x squared plus b squared, we'll call that the other leg, equals 2x squared, which is, or 2x quantity squared, which would be 4x squared. Subtract x squared from both sides, you have b squared equals 3x squared, take the square root, and then you can pull out an x from that square root, and we have b is equal to x root 3. So therefore, for all 30, 60, 90 triangles, the side, if we call the side across from the 30 x, then the hypotenuse, which is the side across from the 90, is always going to be double that, 2x. And the side across from the 60-degree angle is going to be x times root 3, which is, root 3 is a little bit less than 2. Which also follows what we learned in geometry, that is that the smallest angle is across from the smallest side, the biggest angle is across from the biggest side, and the middlest angle is across from the middlest side. In our next lesson, in Lecture 5a, we're going to talk about how to use these, but this activity was mostly just to kind of see how all this came about, and then also to derive those two formulas so we can use them. Alright, thanks for watching, and sorry you missed class.